Nice, it's working. Okay, so hello everyone. I'm gonna talk about performance. The topic is pretty long, but you will see that it's much easier to get. So my name is Filip. I'm a co-founder of Vue Storefront. I guess it needs an explanation what Vue Storefront is. So it's an open source project, probably the biggest e-commerce open source project on Vue right now. So you can find it on GitHub. It's basically a headless frontend for backend. So you can connect it to anything like Magento, something like this. I'm also a front-end developer at Devante. We are kind of a top-of-mind e-commerce software house, and we are working with Vue. And I'm also a community partner of Vue.js. So let's talk about performance, like mostly loading performance, because it's a huge topic. So how many of you think performance is important, is very important? Please raise your hands. Like, okay, half of you. Okay, so I will try to pretend that I'm smart and that I did my homework, and I will show you some numbers to convince you that it is really important, actually. So first of all, it's good to know that we are basically needing 1 second for the user for a mental context switch, which means after 1 second they can potentially leave our website. So we really need to take care about performance to keep our user on the website. Now let's go to like more industry numbers. So for the Firefox, they improved loading time 2 seconds, and it resulted in 15% more downloads. So for Firefox, I guess it's pretty huge, like more than 10 downloads. Also, for Aberdeen Group, 1 second slowdown of the website, so actually worse performance, resulted in 11% less page views. So again, pretty huge number. For Bing, who is using Bing? Okay, so 2 seconds delay resulted in 4% loss in revenue per visitor, and almost 4% reduction in clicks, 2 seconds only. And for Auto Anything, cutting page load time half directly resulted in increasing sales, 13%. So given all these numbers, we can assume that speed equals money. Is it okay? Okay, so I hope the people that didn't raise their hands were lazy, or the other ones that didn't raise their hands are convinced that loading performance is very important. So now it's time to dig a little bit deeper and learn what influences this performance. So first of all, when we want some resource, we need to request for it. And then server responds with response. And the bigger file is, the longer we need to wait for the response. Once we have a response, it needs to be parsed. The bigger file is, the longer it takes to parse it. Once it's parsed into like kind of a nice AST that browser can work with, then we need to execute this code. And guess what? The bigger file is, the longer it takes. So basically, as a front-end developers, we don't have that much influence on how long we need to wait for the server to respond. But we can certainly control the part with parsing and execution. So right now we'll focus on this. We'll see later that there are some things that we can do about response time. So let's investigate what problems we can encounter by making an app. So we all use Vue.js, so it usually starts like very innocent, like a main component, Vue.js imported, root component. But probably after 5–10 minutes, it's gonna be like this. So we'll have a router, another route, all of this bundled into the main bundle. And as we know, every new module or library that we will add to our application is a bigger bundle. Bigger bundle equals longer download, longer parsing, longer execution. And we know that speed equals money, so it's obvious that more feature equals less money. So we just basically need to ship less features. Yes? Yeah, of course not. That's not true, but it may look like, but it's not true. But it's true only if we are not doing any optimization. So to understand how we can deal with the problem of growing bundle, we need to understand how this bundle is constructed. So actually how Webpack bundling works. So it looks like when Webpack is bundling our files, it's creating something called dependency graph. So it's taking the entry point, looks for the imports in this entry point, adds the imported files as a leaves. Next, recursively goes to these files, find their imports, and adds them to the tree. And at the end, bundles it all together. So like to better understand it, let's see it visually. So we have a main.js. Now we are adding all the imports into the dependency graph. Okay. The only one with the dependencies is router.js. So now we are in router.js. We're adding its dependencies to the dependency graph. Now only one is about.vue. We are adding its dependencies to dependency graph, and voila, we have our bundle. But there might be a problem, because depending on some circumstances like state of our application, we might not need some of these modules. So even though they are not needed, they are still downloaded in this big app.js file. So this is why in Webpack we have something called code splitting, and it basically allows you to cut half of your dependency graph and load it later. So create a new file and put some things here. And with this code splitting, we also have something called lazy loading. It's basically loading these chunks, these deferred parts of dependency graph lazily, usually just when we needed them. And the syntax for this is pretty simple. So we have two types of imports in here. The one on the top is a static import. So if we import our file like this, it will be added to the main bundle. But if we will use something called dynamic import, this is actually a function that returns an import. This will be kind of like entry point for a new bundle. It will be still part of the same dependency graph, but from this moment on, every imported file inside lazy component, everything inside there will be in separate file, and, which is very important, it won't be downloaded until this function will invoke. So we can create a new router with this dynamic imports, and by making this, we are making sure that only the route that user is visiting will be delivered to them. So it will look more or less like this. We will have 3 bundles produced. The one, app.js, is basically the one that is shared. The second one is for the home route. The third one is for about route. And if you're using Nuxt, they are doing per route code splitting out of the box, so we don't need to take care of this. So rule number 1, split your code per route. And basically this will give you like the biggest optimization that you can do for your application. And if you take a look here, it's not a big deal to do this. So it's really worth it. Okay, but this is not everything that we can do, of course. What else we don't need on initial download? Any guesses? Yeah, you're so shy. Okay, so we don't need top pop-ups, of course, because they are opened or they are not opened, but we certainly don't need to download them right ahead. Some off-screen sidebars. Basically, all off-screen components are not needed. So we also can code split them and load lazily. So rule number 2, load off-screen components lazily. And how we can do this? Basically, it's very easy. We can, for example, use VIF for this. If you will take a look here, we are also using dynamic import instead of static import. And how it works, we have this VIF in here. And if it's not evaluated to true, then this component will not be rendered. If it won't be rendered, then the function here will not be invoked. And if the function will not be invoked, the chunk will not be downloaded. So basically, VIF is a great way to dynamically load components, like conditionally. So what else we can do? Any guesses? Don't be shy. Okay, I heard Lodash. This is a good answer. Also, my example will be with Lodash. So rule number 3, load non-critical libraries lazily. Non-critical libraries are basically libraries that are needed only for some certain actions, mostly actions that are kind of a response for user interaction. So Lodash can be one of them. So we can use it like this, import Lodash on a function. So only when this function is invoked, Lodash is loaded. Also, when we are speaking about libraries, there is a common anti-pattern used by developers. We like to bundle all third-party libraries into one file, so we have all of them right ahead. There is no code duplication, etc. But in fact, it's an anti-pattern because, again, if you will bundle all the third-party libraries into one file, on some routes, we might not need them, so user ends up with redundant code. So the basic code splitting based on routes is good for this, but you will probably ask me, hey, what about code duplication? What if we will have set up like this? We will end up with duplication. And this is certainly not a thing that we want. So it's very, very easy to solve it. We basically need to use Webpack split chunks plugin and specify the chunks property to all. It means that we are actually telling Webpack, hey, optimize all chunks. So right now, the shared Lodash will be put it into separate chunk, and every shared module will be put it into separate chunk that will be downloaded along with the others when needed. Actually, Webpack will take care of putting it in the right places. So by staying in the topic of the libraries, when we are choosing libraries, we have many to choose from, like, for example, choose slider. If I will ask any of you what slider is the best, probably everyone will give me a different slider. So we really need to choose our libraries carefully. We also have many options for some use cases, and it's not like one library is always the best one for such use case. It's also very good to find smaller equivalents because some of them have like tons of features that we don't need and are not reshaking friendly, etc. So there is a nice website called Bundlephobia. How many of you know Bundlephobia? Okay, not that many. So basically on Bundlephobia, you can type the name of the package that you're using, and it will give you amazing numbers how this particular package will affect your performance. And what is even better, it will give you some alternatives. So you can choose and find some smaller equivalents, or maybe bigger equivalents, but with better features. So it really allows you to pick like the best library for your use case. So this is great. Okay, so I previously told that we don't have that much influence on how fast our server is responding with the resources, and this is true. But actually, we can do some magic because we can make use of the assets that we already have downloaded. So rule number 5, make use of cache for static assets. And what is the best way to do this? To use service workers. Who knows service workers or work with them? Okay, more and more people, but it's still not like a most popular technology. Basically, service worker is kind of a proxy between our client application and its backend. So every request that we are sending is going through this service worker, and service worker can decide what to do with it. So it works more or less like this. And having this, if we already downloaded some files, we can put them into cache and do this. So the request is going to the service worker. We are checking if we previously downloaded some files. The good news is service worker cache is persisting even when the browser is closed. So actually, it can even work offline. So we are giving kind of a feeling of instant loading when we are saving some parts of the application from cache. Like you can imagine that we are saving all the static assets like HTML, CSS from the cache, and then lazily downloading the data to populate this. So it gives like kind of a feeling of instant loading. And if you want to make use of this, if you're using Vue CLI, there is a PWA plugin, which installed will cache everything from your this directory. Installation is very, very, very complicated, like this. Also, if you're using Nuxt, there is a PWA module. Installation is 2 times harder. And in both cases, if you will take a look at your application tab, under cache storage, you will see which files were actually cached. So you will see which files are served from cache, which files are served from the network. OK, so we are taking as much as we can from the resources that we already had. But what else we can do? Because the biggest advantage of having everything in one bundle is that user needs to wait some time at the beginning, but later he has everything like right ahead. Everything is downloaded. So how to achieve this with splitting this our bundle into smaller chunks? So there's a technique called prefetching. It's basically downloading assets before they are requested. So rule number 6, prefetch lazily loaded resources. And it's extremely easy to use it. If you want to like explicitly prefetch some resource, you can use Webpack magic commands. And this magic command will actually generate this link, which will be added dynamically to head of our website when the given route is visited. Also, we can use like more general approach if we don't want to explicitly tell it, or when we want to make some kind of regular expression or generated by the content from our this directory. Then there are plugins that we can use for this. I highly recommend using Workbox because it's basically a set of tools for progressive web apps and caching, etc. And the good news, if you are using Vue CLI free, they are prefetching every code splitted chunks out of the box. So it's kind of nice that we don't need to take care of this. Usually people are asking on Stack Overflow how to disable this. Of course, you can't forget about compression, minification, all that stuff that some of you probably have no idea that Webpack is doing for production, or your DevOps team is doing this, or the guy who set it up Webpack in your project is doing this. OK, so basically this is almost everything you need to know to have a performance web application. Of course, there are tons of edge cases. There is also a case with rendering, which I don't have time to. But you also need to take care of layout reflows, so it has reasonable FPS, etc. But once we know the techniques how to optimize, it's good to also know how to measure it. Because when you can't measure, you can't really tell if there was any improvement. So the first tool that is great just to check how your website looks like in terms of performance is DevTools coverage tool. So to use this, we just need to type Command-Shift-P, which is basically a kind of a finder for Vue DevTools, for DevTools. Then type coverage, and it will give us a very nice information about the website, how much of the code that is there was actually executed. This one is from vuejs.org. So we can inspect every file and see actually which parts were executed, which were not. Of course, it's not like it's impossible to have everything on green in here. Like 50%, 60% is great, because not every code is always invoked. There are third-party libraries, etc., which you're probably using only some parts of their API. So this is only like a guidance for you to check which parts can be optimized and to see what actually is the state of your application. OK, so once we have this and once we know how much we can optimize, it's good to use Webpack Bundle Analyzer. It's an amazing, amazing tool, and I highly recommend it to everyone. Because with Webpack Bundle Analyzer, we actually visually can see which modules are landing in which bundles. And what is more important, if we highlight any of this, we can see how much space they are taking, etc. So we can easily, and of course, the bigger the square is, the more space it's taking. So we can visually see which modules can be, for example, exchanged, lazy loaded, or something like this. The installation is not so hard, I guess. We just need to import it and register as Webpack plugin. So this is the tool that I'd say will help you with 90% of the problems. I was optimizing Vue storefront for 2 months using only this, and we cut off our bundle size more than 60%, so pretty nice. Also, if you want to be sure that you're not exceeding your performance budget, there is a great package for this. It's called bundlesize. So you can install it, and it will prompt you if the output bundle is bigger than you specified in your package.json, for example. They also have a great integration for GitHub. How many of you are leading some open source projects or maintaining? OK, so it's really, really useful for that case. Also, if you want to know right ahead in your VS Code what is the size of the imports, there is an import cost plugin. So if you will install it, if you will import anything, you will see the size. So it's very, very helpful, just in case you import the whole Lodash and wonder why your site becomes slow or something like this. So that's all from me. I hope you learned something useful, and I hope it wasn't something you already knew. If you forgot something, everything will be fine. I will post the slides. Probably James and at vuejs.amsterdam Twitter will share it. So thank you very much.